Hey, what's up, guys? So today I want to discuss something about programming as it relates to separation of concerns. You might have heard of it if you've been around long enough. This may not be new to you, so this video is probably not for you. But for those of you that just starting out in programming, a lot of times you may get an assignment or you may get some work and you want to write your code, and that code may entail popping up a menu that has the user enter some input, and then you have to gather some data. But then the problem comes in where you don't know how to separate what. And since you start thinking in terms of objects, and objects can do anything, they can have methods and data and behavior, you start thinking, well, I can put everything in this object. Well, you don't want to necessarily do that. You want to separate your logic. Now, if you get into the concepts of something called domain-driven design, you have different types of objects, different types of classes. Just like in the world, we have different types of objects. We have objects that are tools. We have objects that are containers, living spaces, vehicles, just different things. We have persons, and so on. Some objects really were interested in the data. And usually in the domain-driven design world, those are called entities. And entities should only really hold data. And then you have service objects. Service objects, and don't think of them as any kind of web service or anything like that. Just services, things that do things. So in this case, let's create something. Let's create a simple application that maybe just takes and does something very simple like a bank account. Let's just say a transaction ledger, right? So the first thing we want to do is create a main. Let me go ahead and add a main to this project, and I'll just call it main CPP. I don't want to create a class. I don't know why it gave me a class. I want to just create a main CPP, so let's add that. And of course, we include IO stream. We'll create this very simple. Make sure it runs just so that we have everything in order. And it's not going to do anything. It's just going to run real quick. Okay, it did. It ran. And so let's create a class. And this class, we call it transaction. And this is one of those types of, it's just really a class that holds data. It can be considered an entity if you think of it just as a data record. So we have a constructor, we have a destructor, and let's add a couple more things. Let's add some private data. And we just, let's just add something simple. Let's just add a date here. And let's add an amount. So let's make it a float. And of course, we have to create all our getters and setters. So let's do that. Let's say, and we need the setters as well, the setters of void. Get rid of this. And let's include string. Let's save that. And let's go ahead and add these methods to our, or member functions to our CPP class. Notice that our class, all it's doing is providing access to the data for getting it and setting it. So and so that's really all there is to this class. Of course, if you really wanted to make this class function like it's supposed to, you would want to have a copy constructor that has the transaction, and you would also want to have the assignment operator. So we have to add these two to our code. Somewhere down here, we already have the structure, so we don't need that. And we need to just qualify it. Oh, this is the wrong place. So this is our basic class, very simple class. Of course, we want to have something that maybe has a ledger of the class, and we want to be able to track the transactions in a collection of some sort. So you notice that I didn't put any input, any way to get input here. I can create a class that has the ledger, and maybe the ledger does it, or maybe the ledger doesn't. Maybe the ledger is just an aggregate for transactions. But we want to keep that separate, so I can just add another class. And I'll call it my ledger. And I go ahead and add it there. And let's get rid of this. I don't like the pragmas because those are really for Visual Studio or Microsoft or whatever, and then you can't convert your code over to other systems. So in this case, the ledger, the only thing that we want to be able to do maybe add transactions. It just keeps track of the transactions. And we don't even need to do that, but I'll go ahead and add it. Maybe a ledger is going to be our input, or we can use it as our input, or we can use it just to hold the information, make it an aggregate. But the idea is that you have the ledger, the transactions separate. So the ledger, we can say that we can have transactions in it. So let's go ahead and add let's include vectors. And here we're going to have private, and we're going to have a vector of type transaction, and we just call it transactions. And we can include our transaction class. And we want to be able to add transactions to this. So we can just add something, say add transaction. And we want to be able to, let's say that we want to be able to get all transactions, but maybe we don't want to pass that over. Maybe we just want to be able to view a particular transaction, or we want to maybe display the transactions, but that still may be something that's separate from this. So in this case, we may just want to be able to display the transactions in which we would pass it a vector of transactions. So we could say something like that. So we separated our class, and now we can add this functionality in our ledger CPP. Place it here. And we can just say transactions. Oh, I thought I had, I do have transactions. Let's go to our ledger. Oh, that's because I haven't added ledger here. And let's say, for example, that here we want to actually display the transactions. Now, is that the responsibility of this thing? To display the transactions may not be the responsibility of this thing. So we may actually have something else that displays it, or maybe this just returns the transactions that we have in the ledger, and we return them back so that they can be accessible somewhere else. We can actually have it where instead of having display transactions, because that's probably not the responsibility of this, that we have a vector of transaction, and we say get transactions. And we go back to our ledger. And here we just say get transactions. And this thing is very simple, but let's see, this is going to be a vector. So now we may actually have something else that's responsible for displaying or adding transactions or anything. And we're going to say, we call it the, let's say the transaction interface or user interface. And our user interface is a different type of class. It's a service, and it's going to, let's say that it's going to display transactions, and it's going to take a, let's not even make it constant, just make it ledger. Or maybe it just says transactions altogether, so we can just take a vector of transaction. And maybe we can add transactions. And let's stay uniform for this. Let's make it lowercase. But now when we create a transaction, we may want to return an actual transaction because it's just our user interface. So now let's think about this though, because we may actually want to have the user interface interact and have the responsibilities of just providing the interface for the user. So we can actually add the transactions here, or we can actually just pass it the ledger and create the transaction there. So let's do that. Let's say that we make it void and we pass it the ledger. When we create a transaction. And we have to include it up here. And so now we have our user interface. So let's go ahead and take this and put it in our user interface. And for our transactions, let's say we do something simple, just a simple for loop. And we render the transactions. We do something simple. And we have to actually include IOStream. And to create a transaction, since we have the ledger, we can have string for date, and we can have the string for the amount string. I'll call it amount string, and then we can say enter the amount. And then we can actually take a transaction, create a transaction, and let's make this a little better. You should not abbreviate anything. That's just bad practice. I did it earlier, but you shouldn't do it. So then we create the transaction, and we say the transaction, we're going to set the date to the date. So we just have the amount here. We actually need the date as well. So let's go ahead and put that there. So we set the date, then we set the amount. and then we simply add it to the ledger. So there we have a user interface that's responsible for getting in the user input and output. We have a ledger that of course has the transactions. And then of course in our main it's very simple. All we have to do is create a user interface. We create our user interface. And we have to include it up here, of course. And we instantiate one. And if we want to have a menu or anything like that, we just can simply say something like and we could actually take it and display it as a function, but let's not do that. Let's not overcomplicate things. We have to declare these up here. And we have to include string. So now we can go to our menu option, whatever was selected. And if our menu option was to, let's say, view transactions, so we say case 1, we simply go to our user interface and say display transactions. And if they want to create a transaction, we could say it actually needs our ledger. So we need to create a ledger. We actually have to declare a ledger up here. We have to bring that in as well. Oops, I put a period instead of a colon here. And we want to, for case 2, we want to create a transaction, which we're just going to pass our ledger. And of course, now we put this in a do while loop. Q for quit. right? So, or we could say menu option. Actually, it's better to say menu option not equal 3. So, so as long as they don't quit, then they do that. But you notice how everything's kind of set up to separate the responsibilities. So the transaction has a very simple functionality to just have information. It's kind of like a record. The ledger is an aggregate that holds transactions in it. It has transactions, and you can add a transaction or get the transactions, and the user interface handles all that. And in actuality, this menu, this main menu, can be simplified if we take it like this and say user interface uh, void display main menu, and we will add that in our user interface. And actually, we want to make it an int. And one thing that I forgot to do for my user interface is to qualify my member functions. And the reason I want to return an int is because I can leave these here. I'm going to pull these two here, but I'm going to get rid of that one. I'm going to go to my user interface and add those here. And when I do that, I'm going to return the menu option. I need to make sure that it returns an int. So now I have that in my main menu. So now when I go to my main, I can say menu option equals user interface, display main menu. And now I have that. And of course, let's see if this actually works. So we build it. Like I have some errors, so let me see this. That's because these are size T. Or I can cast it. Let's see. See what other errors I have. Undefined class, so class redefinition. If it's using redefinitions, it could be because I need to say if not defined, define ledger, and then put my end if here. Transaction class, same thing with the transaction class. Oops. Let's see what errors we have now. Must return a value. Okay, so now it seems like it builds. Let's see if it actually runs. Okay, so we view the transaction, there's nothing there. But let's create a transaction. Date 2020-01-01. Amount 2099. Let's create another transaction. 2020-09-01. And let's make the amount 1999. Now let's view the transaction, see if that works. And you can see my transactions there, 2 transactions. So it did work. And it's very rough and everything else, but the main idea here is to be able to separate your logic. So when you have a ledger, you have that, it has the responsibility of just being a ledger, and the transaction, just a transaction, and your user interface handles all the user interactions. And then that way you can actually reuse your classes if you needed to, because they're not tied to this information, because you may actually need the transactions for something else. Anyway, that's all I have. If you like this video, give it a thumbs up. If you have any feedback, drop a comment down below. And if you want to see any other videos, uh, just let me know what you have questions about. And if you enjoy watching this channel, just make sure to subscribe. That really helps out. Thank you.